So today, let's look at some distributed system architecture. So let's look at first one, a cluster distributed system. So what is a cluster distributed system? As you can see the definition, that is a system where multiple independent servers, we call it as a node here, work together as a single logical system to provide scalability, reliability, and high availability. So these nodes are typically connected via internet with each other so that they can coordinate and they can share the workload. So here client, whether it's tablet, computer, mobile client, they send a request. It goes to a load balancer. And then, as usual, load balancer will distribute it across multiple servers. So that is what we have seen so far, where the load balancer will distribute all the requests to the backend servers, and it will go to either server 1, 2, and 3, and there are different strategies what we have seen. But in this case, the server 1 itself not a single machine or not a single server. Here it is, you can see in this diagram, I've shown that the server 1 is behind the scene, is a cluster of nodes or cluster of servers, where the request will not go to a server 1, but it will go to a leader node, where the responsibility of leader node is to send this request to the other nodes. So you can see there are multiple nodes available. When I'm saying node, it means backend servers only, but they are acting as one entity or acting as a one logical system where the request will send to one node, two node, three node, and they will work together to finish the given request, and they will respond back to leader, and the leader will respond back to the uh, load balancer itself. So the whole idea here is there's no one server who is acting or working to fulfill that request. Here, there are a number of nodes working together. It may possible that node 1 may be an active node 2 may be a passive node. So there will be a failover mechanism where if one node goes down, another will take care of the request or fulfill the request. So and any time any node goes down, all other nodes will be aware of that, okay, node 2 is down. So whatever work that node 2 was performing, it will be taken by maybe another passive node, which is available behind the scene. And there will be continuous replication of data also happening. But the whole purpose of this entire cluster of node is to serve the request as soon as possible. So that is what the whole idea, like we can scale this system or this entire cluster by putting more nodes into it. It is reliable, it is highly available because all failover mechanism will be taken care by itself. Okay, so this is a kind of system where mainly it is to make your distributed system, whatever you're designing. So that should become more scalable, more reliable, and highly available. That is the whole purpose of this kind of system. Okay, so that kind of fault tolerance will be there in this system, and also kind of coordination mechanism. Like if one goes down, another will immediately take over the load that is with the one node, and it will start working to just to give the required outcome or required response as quickly as possible back to the load balancer. So that is the whole purpose of a cluster distributed system. All right. So what is this leader follower, or sometimes we call as primary replica model in distributed system? So here, one node act as a leader that we can call it as a primary node. So you can see here in the image on top, it is called as a leader. So it's a kind of primary node or server, and one or more nodes are followers. So I have mentioned here all are follower 1, 2, 3, 4, and these are all replicas. So leader is responsible for coordinating the system, and the follower will replicate the data or state of the leader to stay in sync with it. So that is the whole idea. Again, I'm repeating, leader is responsible for coordinating, and all other followers are supposed to be in sync with the state or the data available with the leader just to replicate it. So that's why I mentioned here replicate and on. So it will just keep on replicating the data that is available with the leader and the state of the leader. So let's again understand that how exactly it works. See, whenever a client sends a request and it goes to load balancer, it goes to a server, and server 1 is a cluster of server, and the request definitely goes to leader first. So what leader does, it handles all the right operation, make authoritative decision, manage coordination. So these all will be done by leader. So all the right operations will be taken care by the leader, and it then manages the coordination with the followers. So that's why it is a primary one. So primary request will go to a leader. Followers, or we also call it as a replicas, they will receive all these updates. Suppose there is a write request came to leader and request has been fulfilled, and then leader will send those information or the coordination to the replicas or the followers. Then once that update received from leader, the followers will replicate that data and they will update themselves. See, sometimes it is also that these all followers also serve the read request. So as we can see here, the leader will take care of the write operations. But if there are any read requests that are coming, the leader will send those requests to follower and follower will fulfill those read requests. So that is also possible. So in the replication, when changes made on the leader, they are propagated to followers. Whether it is synchronously or asynchronously, that's fine. But it is the replication is happening once the changes are made in the leader node itself. Okay, and if the leader fails, I think we have not seen this in earlier stage, but if leader fails, a new leader will be elected from these followers to maintain that availability. Like there has to be one leader who is taking care of all the write operation. And because they all are sync, so anyone can take that load immediately if this leader node gets failed. That is what we have seen, and it is the same for the other architect also, the cluster architect. But if leader goes down because of any reason, any of one of these followers, because they are in sync with the leader, they can elect one of the leader, like maybe follower one will become a leader and it will start receiving all the write requests and then it will start coordinating with the other followers. Okay, so what is the main use of it? It ensures the data consistency by having single source of truth for writes. So write is going to only one node. So that means there is a single source of truth and then it is getting replicated. It is scalable. So all the read traffic can be diverted to the followers instead of going to leader. And this makes the entire system highly available through replication, through reader election. If any follower goes down, definitely other follower will take care. Here also there'll be active, passive nodes are also there. Servers are also there. This is very useful kind of system, mainly used in databases or distributed file system or coordination service. So this is the widely used because of the high availability of the system and scalability principles also implemented in this. So this is what the leader follower, or we can call it as a primary replica model. See, I'll give you a simple analogy. A cluster distributed system is a company with many employees, where many employees can work together, but they're doing different tasks. Okay, they are maybe someone is working in finance, someone is working on engineering, someone is working on IT. So they have their own purpose, or they are doing some specific task in their organization. But in leader follower model, it's like a manager, or maybe we can call it a leader who's making decision, and team members are following the leader or the manager to execute the task and trying to sync with each other to complete one particular project. So that is how the leader follower model works. I'm just giving one analogy, but here we are replicating all the information from leader, and the analogy talks about the manager who makes a decision. So the decision will be distributed to the team members and team member will execute it. Just like here we are fulfilling the read request. So that is how you can look at both these architecture.